Hello, Insomni'hack, and welcome to our talk. We are Team Pwnhub, seriously not Pwnhub, and I'm Jisub Kim. Thank you for inviting me, and thank you for attending our talk. I hope you enjoy this talk. Okay, here we go now. Again, my name is Jisub Kim, and I'm offensive security researcher in South Korea, and I like web hacking, embedded security, and I'm CTFer, and I'm playing CDF with Team Swag.
Also, my name is Kanghyun Choi, so same teams play the CTFs, like Pwnhub. So, done?
That's it. Okay, today we'll talk about the overall IoT Hub exploitation process from getting firmware and root trail of multiple IoT Hub to Countermeasure. First, introducing the IoT Hub. You guys, do you know what is IoT Hub? IoT Hub is a voucher for connection of the multiple IoT devices called as things. IoT Hub can connect and control things more quicker and easier. And it is used to construct a smart home network or automated smart factory. So why we hack the IoT Hub? According to the Forbes, the IoT market continues to grow, but it's going to be a lot of trouble to manage all of things one by one. So this necessitates a management system that can control a large number of things at once. Thus, the market share of IoT Hub, such as SmartThings, Wink, inevitably increases. And Hub is also a platform designed to manage all our IoT devices at once. So therefore, if you attack the Hub, all devices connected to the Hub will be additional attack surface. So the attacker can dominate the home IoT network with a single exploitation. This table is our process of selection of vendors. First of all, we tried to select based on market share, but we couldn't find the relevant data. Therefore, we selected Amazon's sales ranking that could be an indicator of customer preference. In addition, we also selected 3 Korean mobile carriers that are operating IoT network business actively in Korea. Next, getting firmware. For getting the firmware, we've got some strategies. We list on websites, firmware provisioning, serial communication, etc. The first is when the firmware is released on the website. And this is depending on vendors, but if vendor usually provide firmware for manual updates on the homepage, you can easily obtain the firmware through this route. The second is firmware provisioning. Firmware provisioning is the word that tells how to provide the device with firmware to update. In case of the Hub, usually use SSL encrypted communication to provide an updated firmware. So you have a virtual SSL authentication server between the updated server and Hub, and you can intercept SSL communication to obtain firmware during firmware update. Lastly, serial communication, such as JTAG, UART, It is mainly used for debugging embedded systems. To extract the firmware through serial communication, you must either connect it to the custom shell or send commands to the chips. However, with more embedded device security, most embedded devices have not been able to extract firmware in this way alone. So, we have 2 alternatives. And those are desoldering and side channel attack. First alternative, desoldering is the removal of solder and components from a circuit board for troubleshooting, repair, and replacement. But use of too high temperature of heating, temperature or heating for too long may damage components and board. Therefore, it needs very skillful technique. These pictures show the results when we personally tried the desoldering technique. And we purchased a dedicated socket and an interface board, and we try to dump the NAND flash and eMMC. eMMC has a lot of data in the internet, so the firmware extraction process was not difficult. Its desolder test was successful. But in the case of NAND flash, it was pretty difficult because we had to reproduce the controller role, what eMMC do. Next, we are introducing the side channel attack. Each device had a variety of hardware security techniques depending on vendor. So, however, we thought analyzing it individually and bypassing it was not efficient. So, because the IoT Hub is also an embedded system tool, we decided to analyze the bootloaders used in most embedded systems. According to statistics, most embedded systems use U-boot or CFE bootloader, and because most of the hubs we are going to analyze and using U-boot bootloader, so we are going to analyze the U-boot bootloader. At system booting, the bootloader initializes peripheral devices such as CPU, memory, and enters the main loop function. The main loop function finally executes auto boot command. If success, the OS boot, but if fails, it returns a custom shell for the developer. When auto boot command is executed, the physical memory map is overridden by Linux kernel. If an error occurs, auto boot command function returns the value without running the kernel. But the main loop does not handle the return value when the exception occurs in there. So CLI loop function is run sequentially and U-boot falls back to the custom shell. So if an error occurs before loading the kernel, through a glitching attack, pin-to-pawn attack present in DEFCON, the CLI loop function is executed and the custom shell is returned. As a result, we got CV number for that vulnerability, and we've been able to get firmware from most IoT hubs in these two ways. Next is defining attack surface. In order to analyze the vulnerabilities with extracted firmware, the attack surface must be well defined. So this requires detailed threat modeling and accurate understanding of data flow between hub and server. Because most vulnerabilities occur in the user's input, so we must draw a data flow first to specify how all data flows. Therefore, it is necessary to draw a data flow that can be applied to hubs in general. Data flow diagram from IoT devices to servers should be detailed as follows to specify attack surfaces. And using defined data flow diagram, we analyzed where there would be a threat in the data flow. And we used the STRIDE for effective threat analysis. And STRIDE stands for spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privilege. And it is a method created by Microsoft to identify threats and to define threat model. Nowadays, Many security researchers are using it a lot these days. Finally, in the results of threat analysis, a total of 53 threats were derived. For more detailed threat modeling, we have created Attack Library. Attack Library is a tool that details threats about the system in threat modeling. For building an attack library, we should collect a lot of suitable materials about a purpose and usage. For example, standard technique documentation, papers, conference, the vulnerability information released at CVE, CWE, and the vulnerability information released at OWASP were used in this case. As a result, we can draw an attack tree based on stride and the FT we previously defined. The root node was set up as a case of attack on the home IoT network, and smart device, service, smart home devices were set up as follows, such as a trust boundary in stride threat model. Finally, we can identify a purpose of the attack and analyze the threats we defined through these works. And by doing so, we can give shape to a plan about where we start specifically and how to attack systematically the target. And then we are going to talk about some of the interesting one-days that we have included in our attack library.
So next one-day case study. Why did we do one-day case study? Because we need to run that most similar case to find more efficient vulnerabilities. Our team ran a lot of vulnerabilities by collecting one-day case. One-day case refer to vulnerabilities and research reference reported by many companies, such as Talos, Rapid7. Many of them were found at Talos 7. We found some conclusion for one-day case study. First, we ran that found the most vulnerabilities in the user info function. Most of the function did not verify their size. The most interesting vulnerability we've seen while running is MITM. On that part, we are going to get ready for a real magic show. Okay, let's start. What is our one day to introduce? We talk about two memory corruption in SmartThings Hub and a radio frequency replay vulnerability in Insteon Hub. These vulnerabilities found in the Samsung SmartThings Hub have been found in the Samsung Wi-Fi scan and list function. Based on this, it allows us to write input value without regarding user info size validation. Next, introduction in the one-day case study is radio frequency vulnerability. It is one of the most interesting cases we have ever seen. So let's talk about these vulnerabilities. First, it was memory corruption in Samsung SmartThings Hub Wi-Fi scan function. Most of function in SmartThings was parsing JSON data, then it was being used as string. This case was also same. User parameter in JSON data was taken to user argument. Camera IP, password, callback URL were processed same method. However, while moving JSON data to argument, it used string copy function. So it's meant that copy many string make memory corruption. In Talos, they simply use the call command to write the POC code if you write the payload instead of red text. You can exploit Samsung SmartThings Hub in Samsung Wi-Fi scan function. Second, it was memory corruption vulnerability in Samsung SmartThings Hub clips function. It was same but little different. In this case, instead of string copy function, it used string and copy function. At this time, size value was made by string length function using capture time JSON data size. So it meant that copying many string make memory corruption. Parameters such as start time, end time, correlation ID, and callback URL were copied in the same way. This case exploit the same way like Samsung Wi-Fi scan function if you write the payload instead of red text. You can exploit Samsung SmartThings Hub in clip function. The last one-day case we would like to introduce is RF replay vulnerability found at the Insteon Hub. The Insteon Hub used the FSK communication protocol. Analysis of this protocol revealed that the transmission do not appear to be encrypted, nor to contain any security mechanism to prevent replay attacks. Using SDR, they captured the radio side of garage door control device that opened and closed the door. Then they replayed the radio signal. In result, they successfully found out RF was being replayed. So next is 0 day. Through the one-day case, we found out many vulnerabilities such as memory corruption, command injection, SSRF, backdoor, and MITM. So what kind of vulnerability did we find? We found 5 types and vulnerabilities more than 10. We will introduce memory corruption, backdoor, and MITM in Insomni'hack conference. For first, we will introduce code execution vulnerability in admin page. We were able to verify that process called go-ahead was running in IoT Hub. So we analyzed the go-ahead binary. While this binary tried to log in, it copies arbitrary session cookie. This value is admin session value. At this time, this value is copied to string copy function. So it's meant that copied many string and make memory corruption. We attempted to modify the session value using Frogster Fiddler. As a result, we could see a segmentation fault or error in go-ahead binary. Exploit code was written to verify this vulnerability. And then we got the reverse shell. Second, we found the packet relay vulnerability in the 3MPD binary. When IoT Hub controls things with a smartphone, it sends command. At this time, IoT Hub sends packet to things. So we analyzed this packet for turning on and off smart plug and write. By comparing packet of things, we found that command class and timestamp value were different. So after that, we opened IDA and started analyzing to 3MPD binary. We found routine that compares same value as the command class on smart plug. In addition, we found draw command keyword, another routine that control things packet. So we did an experiment. We sent modified packet to control smart plug. After we got the received data, we discovered that the packet relay was successfully sent. At last, we found backdoor vulnerability. Before we talk about this vulnerability, we need to introduce this IoT hub that we analyzed. Unlikely other hubs, this hub uses OSGI framework. OSGI is a dynamic platform based on the Java. Most of the functions were being used as the Java bundle. We were approaching in a new way because it was being processed in a different way than before. While we were scanning working port, we could see that service was running on port A443. However, it was impossible to access. We analyzed the Java source code and found that we needed the specific value, which was the encoding of the IoT Hub's serial key. So we accessed by using URL next IoT Hub serial key, and we got the login interface. The account ID was admin. The password was the MAC address and serial key. Unfortunately, there was one problem. The MAC address had 2-byte value. We could not deduce. Also, brute force attack was impossible because admin interface was disabled when login failed more than 5 times. We looked for another method and found a special service that could change the MAC address and serial key. So we connected to the service, which is called MESD daemon, and analyzed it. This service was created at the factory to change the MAC address and serial key. We started the analysis by accessing through the change admin account. The most interesting feature is the plugin management function. We wrote the reverse shell bundle and unrolled it As a result, we got the shell. The interesting point of this vulnerability does not stop here. You can unload bundle such as microphone or control of things. The next is the scenario. So what is the fun part about these vulnerabilities? We have made a scenario for hacking your home, such as opening door, controlling plug, changing door lock password. At this time, we will show a magic show how the door get opened. There could be a network issue during the demonstration. As we said before, taking control of the IoT Hub gives us domination over the things. The first, we will start to control IoT things, control IoT Hub using memory corruption vulnerability. There was a network issue during the demonstration, so we will show the video. So we use the fake server, the MITM tool. So control plug, smart plug, and we control the smart door. So actually we was show the this smart door add the number, so and the random number, so and we that's number to open the door. Before we say there was a network issue, so we So, please forget this. Please forget of this. So, we are some real meme. So attention please and say cheese.
Okay, there was some network issue, so I'm so sorry about that. And from now on, we will be discussing how to prevent this security fault of IoT Hub. Now, what we felt when we were hacking the IoT Hub is that it is difficult to find vulnerability in products that had bug-bound program. On the other hand, the vulnerability of products that not operated bug bounty program could be found more easily. Therefore, you can eliminate the security threats that exist in the hub in advance via the hackers. So I think the best way to prevent the hacking of the IoT Hub is to start a bug bounty program. Because most hackers just hack for fun. Of course, money and honor can be a reason for that too. Anyway, the vulnerabilities that are not discovered will be a new challenge for hackers and will make them challenger. and they can make money by way of finding a bug. And we think that developers can significantly improve their security of products via the bug reported by hackers. Moreover, if they learn through the collected bug report, their security level would be improved. In addition, they can make hackers around the world your helper, of course, if they provide a reasonable money or reward. Lastly, conclusion. The IoT Hub is getting safer, but there are still many vulnerabilities in there. So the vulnerabilities that are not discovered will be a new challenge for hackers, and it will provide developers with an opportunity to improve the security of their products. Thus, cooperation between hackers and developers could create the world more safer. And it is a challenge we all have to try. Thank you.
Thank you very much for your talk. As usual, if there's any question, just raise your hand and I'll give you the mic. Okay, no questions. Thank you very much for being here. This was the last talk in this room. So if you just want to hang out or go for a coffee, you're free to do as you want. Thank you.